Okay, folks, we're going to work on parabolas now. So our goals are to change perspective on parabolas to a conics perspective. We've already looked at them, but they have more parts to them than we had previously studied. So now we're going to look at it from a pure shape standpoint. We want to be able to find the directrix and the focus of a parabola, and we want to use the latus rectum and understand what that is to graph the parabola completely. And then we'll graph parabolas facing up, facing down, right, left, and then we'll also translate them about the graph. Okay? Alright, so our parabola can face many different ways and has these formula when the vertex is at the origin. So this formula here only works when the vertex is at the origin. When it's not at the origin, we're going to have an h and a k associated with y. But in order for it to face up and down, it has to be an x squared. In order to face right and left, it has to be y squared. And I hope you notice that only one variable is squared. That's an important distinction because it's the only shape so far that we've had in conics where the x or the y is squared and the other is not. Okay? Again, if x is squared, we go vertical. If y is squared, it's a horizontal. Now, we have an axis of symmetry as opposed to a transverse axis like we did with hyperbolas. We have this thing called the directrix. And the directrix is nothing more than this line that helps create the definition of a parabola. And basically what they're saying is that if I go from this point and I go out perpendicularly to the parabola and I measure that distance, and then I go from that point to the focus and I measure that distance, those are going to be exactly the same. Alright? And that creates a set of points right there that we call the parabola. So if I'm on this directrix, the distance from here to the parabola and then from there to the focus will be identical. And so we can use the directrix to know maybe where our vertex is or where our focus is, or use our focus and our vertex to find our directrix. Alright, it's just part of the definition. So with the parabola, we use this variable p to represent the distance from our vertex to our focus. So vertex to focus, but it's really important to know that this thing here, where it's 0p, only works when our vertex is 0, 0. Alright? If it's not, then p is just your distance. Just like a and b and c were distances from centers to vertices, co-vertices, and foci, same thing here. We only have one focus, one directrix. So p units from the vertex to the focus gives you your focus, and then negative p units, opposite p units, basically finds your directrix. Alright? Alright, so we're identifying the focus and directrix of the parabola and then drawing the parabola. So again, right now what they're telling me is that x equals negative 1/6 y squared, and we said that it had to be y squared equaled 4px. So I'm going to multiply over and get y squared equals negative 6x. So that means that 4p equals negative 6. So p equals negative 3/2. And so if our vertex, since I look and I see that my y value and my x value have nothing added or subtracted from it, I know that my vertex is at 0, 0. So we draw a nice big vertex there. And then my p tells me where to go to find my vertex. Now the question is, do I go to the left or do I go down? Well, y is squared, so we're going to go down 3.5 units and put our focus at 0, 0, negative 3/2. That means our directrix is going to be exactly opposite, at y equals 3/2. Alright, now, the only thing we hadn't talked about so far is called the latus rectum. And the latus rectum actually helps me create my parabola. So the latus rectum, I call it LR, latus rectum, is a line that goes through the focus parallel to the directrix. So this is my directrix, and this is my LR. But we actually cut it off. We actually cut it off right where it would hit the parabola. Well, how long is it? The whole lattice rectum itself is 4p, so it's actually -6. So the LR equals -6 units. So that means that half of the LR is going to be 2p. So I'm going to erase my line here until my LR is equidistant on either side of the focus. So if you notice, I go 3 units left, 3 units right, and that tells me where to put points that are actually on the parabola. And then I can erase my LR because it's just it's a pattern thing, right? So there's my parabola. My LR equaled 6 units, and I guess it doesn't really need to equal -6 units. It's a distance, right? Distance from my focus to here then is, this distance is 2p, and this distance 2p, or 3 units. All right, 3 units or 2p. So just to recap, directrix is equidistant from the vertex, as is the focus. So these two distances are identical. This guy is always perpendicular to my axis of symmetry. Axis of symmetry is what skewers the parabola. Then I look at my lattice rectum, and that's this line right here between the parabola and the focus, through the focus to the edges to the parabola. It's always 4p long, so I go 2p to the right, 2p to the left, put a point, and I've drawn my parabola. I don't have to use an x and y chart anymore. Alright, now we're going to go backwards. We're going to write an equation of a parabola shown to the right. So first thing is, it's pointed up and it's pointed up. So I know right now we're going to use x squared equals 4py. And I always write that. My vertex is 0, 0. That's why I don't have an h or a k. My directrix, I notice, is 2 units down. So this is y equals -2 for my directrix. That means my focus is going to be right there. That's my focus, which tells me that I'm 2 units away from my vertex, positive 2 units. So then x squared equals 4 times 2 times y, or x squared equals 4py, or excuse me, 8y. And then you could write it as y equals 1/8 x squared if you wanted to plug it in your calculator and check it out. Notice that our directrix goes from here to here, and if you count, it's 8 units long, which is 4p. Alright? So that would be how you help it. So you're given the parabola, and you're going back and writing the equation. Alright? Alright, so now we're going to graph an equation that does not have a vertex at 0, 0. So right off the bat, I'm looking at this, and I'm saying my vertex is -4, 2. Alright, so we go to -4 and up to 2, and there's our vertex. Alright, right now this is of the form x minus h squared equals 4p y minus k. So that looks like -8 equals 4p, or p is going to equal -2. And since x squared, I know that I'm going to be going down with this. That's the way my parabola is going to face. So I'm going to go down 2 units and put my focus. And I can see that my focus is at -4, 0. Okay, so we know our focus there is at -4, 0. And then that means that our directrix is going to be 2 units in the opposite direction, okay, at y equals 4. and it's y equals because the y value never changes. Alright, then we need to draw our lattice rectum, and I'm going to do red here. Well, P is 2, so that means that my directrix is going to be 8 units long. So I'm going to go 2 units, 2P to the right, 2P to the left, and now I've got a directrix that's 8 units long, and I can place my points at the end of it. And those points create my parabola. And so the points on the graph then end up being the origin, 0, 0, and negative 8, 0. And they help me figure out how wide my directrix is. And then in order to figure out the axis of symmetry, we just go right through the middle. And this is x equals negative 4. And you have your axis of symmetry. Alright, so recap. Vertex comes from here, negative 4, 2. So we place it right there. Then we say that we have our x minus h squared equals 4p times y minus k. It's exactly the same as our other equation, just with h and k, which were our vertex. Then 4p has to equal negative 8. So p then equals negative 2, which tells me I'm going to go down 2. Because x was squared, so it's vertical, so we're either going down or up, but p being negative tells me I'm going down, which puts my directrix 2 units in the opposite direction and perpendicular to our axis of symmetry. Then our lattice rectum is just this line through the focus to the sides of the parabola, and this line is 4p long, or 8 units long, which means I go 4 units to the right, 4 units to the left. If it had been facing sideways, say, we would have put our focus here, or excuse me, here because it was negative, and our directrix like this, vertically. Axis of symmetry would be horizontal, and then from our focus we'd go up 4 and down 4. If it had been, say, a y squared parabola instead. Alright, another perfect example here. We have a y squared, so we have y minus k squared equals 4p x minus h. So my vertex is at negative 6, 1, and then 4p equals 4, so p equals 1. So let's plot that. Negative 6, oops, forgot the y value there, negative 6, 1. There's my vertex. And then p is 1, positive. And this is going to go left or right because it's a y squared. But because p is positive, I know I'm going to go right 1 unit. Which means I'm going to go left 1 unit and draw my directrix at x equals negative 7, looks like. My focus then is negative 5, 1. Alright, and 4p is 4, so I need to go up 2 and down 2 to get my lattice rectum, which is in red here. And then we just draw right there. Okay, axis of symmetry is y equals 1. And that should be it. Alright, so now we're given different information here. They're telling me that the vertex is at 5, 3. So I always draw everything with these shapes. It just helps me kind of figure out some distances, because it's all about the distances. 5, 3 is our vertex. Then y equals 6 is my directrix. So I'm going to go up to 6. So I have a horizontal directrix here then. Horizontal directrix is telling me that my axis of symmetry is vertical. If my axis of symmetry is vertical, I know I'm using x minus h squared equals 4p times y minus k. Because if my axis of symmetry is vertical, that means my parabola is vertical. But I have x minus 5 squared equals 4p times y minus 3. And then they tell me that my directrix, or I have to kind of tell myself really, that my directrix is 3 units opposite, or 3 units up, so that means that p is actually going to be negative 3, which makes this whole term negative 12 times y minus 3 equals x minus 5 squared. So then my focus becomes right here at 0, or excuse me, 5, 0. Alright, we use our LR in red here. 4p is 12 units, so I'd actually have to come out here to 6 units to the right, 6 units to the left, and draw our parabola. Alright? Okay, hope that helped. So here's our equation, x minus 5, quantity squared equals negative 12 times y minus 3. Good luck.